What's good, mathematicians? This is your girl, PS, Professor Sampson, and welcome to PS I Love Math. And we are back with another banger on our 3-video sequence of the quadratic equation and how to solve the quadratic equations using different methods. So today we'll be going over the square root method. But before you go, don't forget to do what? Don't forget to like, subscribe, can't say it, and comment at the bottom. Let me know what you think. Let me know what other examples you might want me to use. So don't forget to click the subscribe button down there, and let's get it started. Let's not take too long on begging for subscribers, right? So let's go. So I'm going to share my screen as usual, and we're going to get right into it. Don't know what that is. Okay. So we're going to talk about quadratic equations, and we're going to talk about the square root method. So quadratic equations. And the square root method. This is actually the easiest of the three. You have the square root method, and you have completing the square, and then you have the quadratic formula. There are videos. You'll see them at the end that you can go ahead and roll into those other two methods. But just to remember one thing, you want to talk about the zero factor property. Well, the zero factor property just means, if you think about it, A times B, right? And if you say that's equal to 0, then what has to happen? Either A has to be 0, B has to be 0, or they can both be 0, right? But either way, something has to be 0 in the zero product property. And we use this property to do the square root method, and also to do factoring, the factoring method, okay? So let's jump into an example, because I don't think there's anything else that we need to do in explaining it. Hopefully your instructor has explained it to you, and this is just a brief overview with a couple of examples, okay? So let's get into it. Let's say, for example, we have a simple one. Just simply x squared is equal to 121, right? Now, with the square root property, the part of the square root property that's important is that you know that squared and square roots cancel each other out. Just like pluses and minuses, multiplication and division, they're opposites, they're mathematical opposites, so they're going to cancel each other out, okay? The important part about the square root property that most students forget, remember, a square, this should be a part of your teaching from your instructor or your readings, a square really means you're going to get two answers. So we know that in order to get rid of this and get down to our x, we have to do the square root, because as we said, squared and square root cancel each other out. And we also know that what we have to do to one side, we have to do to the other. But when you're canceling a square root with a squared, when you go to square root the other side, you need to add a plus or minus. Now, a lot of students forget this, but if you think about the fact that I circled the 2, meaning you should get 2 answers. So now you get x is equal to plus or minus the square root of 121. And that means x is equal to plus or minus 11, because the square root of 121 is 11. Okay? So nice and easy. So the steps would be first to isolate the radical. Right? And then you take the square root. Right? And then you write down your final answers, of course. Okay? So isolate the radical. In our first example, the radical was already isolated. What if we have something like 3x squared equals 108? Well, isolate the square so you can take the radical. All right, so in this case, the square is not by itself isolated, meaning just x squared. What's keeping it from being isolated? Well, the 3. The 3 is keeping it from just being x squared, okay? So you need to get rid of that by dividing by 3, all right? And then you're left with x squared is equal to, and just so we remember that we have our calculator, of course I could do it in my head, but why would I want to, right? So I could double check and make sure. So 108 divided by 3 should be, right? There you go. 108 divided by 3 is 36. All right. Always feel free to pop up that calculator. Okay. Then you square root both sides. Don't forget your plus or minus. So you get x is equal to plus or minus the square root of 36, or x is equal to plus or minus 6. Okay? So those are pretty straightforward, pretty easy. Let's check a different one where it might not be so easy, or it might not be so easy to see what you need to do. All right? Now this probably is an easier example, but just want to show it to you. All right? So let's say if we had, I don't know, x plus 2 squared is equal to negative 25. Okay? What is that problem about? X plus 2 squared is equal to negative 25. All right? So we go ahead. It's actually the square that's isolated because there's nothing over here other than the square, right? So we're going to take the square root of both sides. Square root of both sides. That's going to give you a plus or minus. So you're going to be left with x plus 2 is equal to plus or minus the square root of negative 25. Well, you know that you can have imaginary numbers as your answer. You should already be working with I. So what is this? This is x plus 2 is equal to plus or minus what? This becomes the square root of negative 25 is 5i. Okay? And then we solve for x, subtract 2, subtract 2. Don't forget we do not combine that 2 with the I. Okay? So we just get x is equal to negative 2 plus or minus 5i. Right? Now, some of your instructors may want you to break it down, or some software programs may want you to break it down into both answers, either this way or saying x equals, either listing the x's or saying x equals. It really doesn't get any much harder than that. I mean, we could attempt to make it harder. Here's an example here, a fourth example here. What about this? 3 times x plus 11 squared, right, is equal to 60. Again, your question is this isolated? And I should say isolate, right, the square, not the radical, all right? Is this isolated? No, this is not isolated because you need to divide by 3 to get it isolated. Now you have x plus 11 squared is equal to 60 over 3, which is 20. Okay, you keep going. Take the square root of this side. Take the square root of this side. This time I left enough space to add the plus or minus there. You wind up with x plus 11 is equal to plus or minus the square root of 20. Okay. But now this time we need to break down the square root of 20. All right. And if you don't recall, you can check out my other videos, but you have 5 times 4, and this becomes 2 radical 5. Okay. So then that leaves you with x plus 11 is equal to plus or minus 2 radical 5. Now you can subtract 11. Subtract 11, and you get x is equal to negative 11 plus or minus 2 radical 5. Okay. And again, your instructor can ask you to write it in 2 separate answers, x is equal to, or your software program. Okay. So as you see, they don't really get much harder. I'll do one more of these type just to let you see. You know, usually I do 4 examples, but I'm going to do a 5th one just because this one may be a little bit different. Negative 3 times x squared plus 15 minus 7 equals 20. Now, your instructor may give you this type of problem for extra credit, just to see if you know what you should be doing. So let's do this one. What you're going to do, you're going to add 7 to both sides, because that's what you move first. You're left with negative 3 x squared plus 15 is equal to 27. Now you're going to divide by -3, divide by -3. You get x squared plus 15, right, is equal to, remember, don't be afraid, even on these. Now, you know, I know this, 27, right, divided by -3. Don't be afraid to use your calculator because you feel like you know the answer. It's -9. A lot of students will forget the negative. All right, that's -9. Right? Now, is this problem like the other problem? No, this problem is nothing like that problem. Look at it. Is there a squared here? And I put the parentheses here to throw you off. But there's no squared here, so there's no need for the parentheses to be here. The parentheses needed to be up at the top. So really, all you need to do with this one is subtract 15, subtract 15. See, always have a banger at the end. X squared is equal to what? -24. See what happened there? Just giving you a second. Now we have x squared isolated. X squared is isolated. Now we can take the square root of both sides. That's going to be plus or minus, right? 24 needs to be broken down. So 24. Some of you might do 6 and 4. Break that down to 2 and 3 if you needed to. And this is 2 and 2, but that's going to be 2, right? So that breaks down to 2 radical 6. So now you have x is equal to plus or minus 2. What? 2i radical 6, right? So your answer is x is equal to -2i radical 6 and 2i radical 6. I always have to throw a banger at the end for you because that's how you stay to the end and make sure you know what you're doing. So that takes care of all 3 types of problems that you can get when you're trying to use the square root property. Okay? So with that being the case, I think that's it for this video. You had 5 examples showing you how to use the square root property, the square root method for solving quadratic equations. I hope you found this video helpful and entertaining. Don't forget, there are 2 other ways that you can find the answers in a quadratic equation. The video should be over here, and the subscribe button is over here. So don't forget to subscribe, like, and definitely comment so we can have a conversation. Other than that, you know who this is. This is Professor Sampson, and P.S. I love math. Goodbye now.